All right, we've been talking a lot about area, and yesterday we did a little bit of work with cylinders. And so today what we're going to focus on is just general surface area of any kind of object, and kind of look at some specific situations, some that are a little out of the ordinary. Okay, so what I need you to do, make sure you got your book and your pencil. This is page 283 in your Go Math 7 book. All right. And it says, how can you find surface area? This is our essential question today. Um, of figures made up of different types of cubes and prisms, and what does it look like? So last year, I think you did a lot of work with some prisms and things. And so just to remind yourself, a prism has a top and a bottom base and then comes straight up. All right. So for example, if I had something like this, okay, looks kind of a cool shaped box. The top and the bottom, and granted you can turn it, I mean now it looks like a tent and so on, but the top and the bottom are triangles and every side is a rectangle. In fact, the lateral sides, and that's what we are referring to as lateral area, those are usually rectangles on a prism. And so if you can start to envision unfolding it into its net, kind of like its two-dimensional map on how it gets folded together, you just take all those pieces, find the areas of each one of those, and add them all up. That's what surface area is. Now, your book will probably come along and try to do some formula work with you, and I'm just saying, you know what? I struggle with you constantly remembering a formula, and I'd rather have you simply understand what you actually are dealing with, break it apart into each face, and then add up those areas. So here we go. Here is a rectangular prism, in other words, a box. Okay, its base has dimensions of 8 by 15, and the height of it is 20. So we have really 6 different sides, and when you unfold the net, you see it like this. What I want you to do is come with me, and over here where you have some room, let's think about what's going on here. You basically have a top and a bottom, and the top and the bottom is a rectangle that ends up being 15 by 8. Okay, those are these two, top and bottom. Then you have a left side and a right side. Those are also rectangles. Those happen to have dimensions 20 by 8. That's this one and this one on your net. So they're kind of tall and skinnier, 8 and 20. And then finally you have your front and your back. The front and the back are these rectangles, okay, right here, right here. They happen to have dimensions of 15 by 20. Okay, so here's what it's saying here. Lateral would be all the sides. So that would be the left and right, these two, and the front and back. One of these left and right sides is 8 by 20. 8 times 20 is 160 square millimeters. So we've got 2 of those, all right, because that's your left and your right side right there, left and right. That's why they put a big old 2. Next, you have the front and the back. Those are the ones that are 15 by 20. So if you take 15 times 20, that gives you 300. And we have 2 of those. Okay, we still haven't dealt with the base, the top and the bottom base. And so we're going to put those here. The top and the bottoms were 8 by 15, and those are 120. Now, the only thing I don't like about what your book does here is that it says each base is 120. You have 2 of those. So really, what you need to do is take 2 times 120. Write that down there because they do that up here for your lateral area and they don't do each base. And I prefer you do that. That gives you 240 there. Multiply these two. 2 times 160 is 320. 2 times 300 is 600. So the sides are 920. The top and the bottom bases are 240. So the total of the entire shape is 1,160. Okay, and let's label this thing because it's millimeters. So we'll call it square millimeters. Okay. For now, I'm going to have you kind of skip over this reflect question. What they want you to notice is that you could get this lateral number, the 920, all in one multiplication if you simply say, what's the perimeter of the bottom, and zoop up the sides, and that would give you the whole side. Okay. And frankly, if you see that and you want to use that as your method, knowing that's going to give you the left, right, and front and back rectangles, 8 plus 15 plus 8 plus 15, that's 46, times 20, the height, whoosh, that would give you your 920 altogether. Okay, so I guess now we've kind of answered this one. How does the product of the perimeter and the height compare to those? You can say they're the same. Okay, all right, let's move on. Okay, this example, they work that through, and you can use that as a reference if you choose. But right now, I'd like you to look at question number 3 on the Your Turn. You have a box from spaghetti, kind of like a box of Kleenex or facial tissue or whatever. Same idea. They didn't give you a picture, but they said the length is 9, the width is 2, the height is 1.5. So they're envisioning that this thing is laying down on its side. Usually I think a spaghetti is standing up, but that's okay. All right, so it says it's 9 inches long, 2 inches wide, and the height is 1.5. So now it's the same thing. I want the area of the whole thing, kind of like wrapping the package at birthday time, okay? So we have your two bases, which are your top and your bottom, okay? So the top and the bottom, let's figure that out. The top and the bottom is the rectangle that's 9 by 2, okay? That gives you 18. You have 2 of those, okay? So if you want to write 18 twice, that's fine. If you want to write 2 times 18, fine. If you want to write 18 plus 18, fine. Next, what do you want? Let's do the front and the back. Okay, so now we're taking care of the lateral area all around the sides, front and back. This is this skinny rectangle here, and this happens to measure 9 by 1.5. Okay, so let's multiply that up. Base times height, or length times width. 9, 4.5, 13.5. And you have 2 of those. Okay. Last but not least, we haven't talked about, hang on, I'm trying to get the page to cooperate here. Now we have to talk about, which ones? Oh, the left and the right. Left and right sides are these tiny little rectangles that measure 2 by 1.5. Multiply that to get your area. That's 3 for each of those. So here's what you've got. You've got 2 18s, you've got 2 13.5s, and you've got 2 3s, and you need to total those up, okay? 18 and 18 is 36. 13.5 and 13.5 is 27. 3 and 3 is 6. Shazam, let's see, that's 50, 13, 63. I think I get a total of 69. And because we're doing area, it's square inches, okay? That would cover all of those sides. Next, what I want you to do, here's another one for reference. It's not exactly just a box. It has some different shapes. So what I would like you to do is follow along with me, and we're heading over to page 286. Okay, I'm going to walk through a couple of these with you so that you can kind of see what happens when I have some overlapped regions and what's going on here. So let's start with number 4. It says Dara is building a plant stand. She wants to stain the plant stand except for the bottom of the larger prism. So it's like stacking boxes. She's not going to bother staining the bottom of this one. Okay. All right. Now, the nice part is these are cubes, which means every single face is the same side. Come over here and let's talk about this. Here's the smaller one, the one that's on top. It's 8 by 8 by 8, like this, okay? That means my top and my bottom are 8 by 8. That means my left side and my right side are 8 by 8. My front and back are 8 by 8. So 8 times 8 is 64. That's one face. Let's say like the front. But you have 6 of them. Front, back, top, bottom, left, right. So really, we can take 6 times 64 and get your total there. Grab your calculator and crank that one out. I think it's 384. Okay, let's leave that number there. Let's talk about the big box. The big box is the same thing. Every single face is 12 by 12. You have front, back, top, bottom, left, right. There's 6 of those. Now hold on, I know we just talked about the fact that we said she's not going to paint the bottom. Hang on. 600 and 240 is 840 and 24 more. 864. Check it on the calculator. I haven't had any coffee yet this morning. Now, here's the deal. If we were doing all 6 sides of each of these, I would say just add them up, okay? And if I did that, I would get like 1,100, 1,200, I don't know, a big number. Problem is, though, she is not going to do the bottom of the big box. So what we need to do is we have that 684, but we're really taking off the bottom because she's not going to bother staining that. No one's going to see it. 0, 4. All right. So we have 540 for the big one, and then we have 384 for the little one. So what I would think of doing is simply adding these two together now. Take 540 and then add the 384 for the smaller one. And when you do that, 8, 9, I got 924. Okay. And then when I put that in there, and I looked in the back of the book, that wasn't the right answer. Okay. Or I should say the handy dandy teacher's edition. So I was like, something's not correct here. Then I thought, well, maybe she's also not doing the bottom of the little box because no one's going to see that. Each of those was 64. So maybe I need to subtract 64 to get that. And that would give me 860 now. And I checked that and I said, no, that's not it either. And I was like, oh. Well, then maybe she's also, since this little box is covering the top of a little square on this big box, maybe we have to take off another 64. So when I took off 860 minus another 64, I got 796 square inches. And that's what the book said. That's what they were after. I don't know if the directions were as clear on that one, but okay. And frankly, if you would have gotten to this 924, I probably would have gone with saying that's okay, even, because it wasn't really clear that she also wasn't going to stain that part. So, all right, there we go. Let's take a look at a few of these here. In the guided practice, I want to talk about this guy because it's a triangular prism. And here's what you've got. And I don't want to tackle it this way, okay? I want you to think of it this way. You have 2 triangles. They're exactly the same size, okay? And it's kind of hard to read this diagram down there, so that's why I'm redrawing it here. The bottom of that edge of the triangle is 8, and the height is 3, okay? When you find the area of a triangle is really half of a parallelogram. And a parallelogram, you just go base times height, but then you take half of it. So one of these triangles, 3 by 8, 3 times 8 is 24. When you take half of it, that would be 12. So the area of one of these triangles is 12. But you have two of them, okay? 12 and 12. All right, now here's the kicker. You've got these three rectangles. This one in the front is 7 by 8, okay? 7 by 8. So that gives me an area of 56. Then you have these two rectangles in the back that happen to be 5 by 7, okay? These guys are 5 by 7, and you have two of those. So that's a 35 and a 35, okay? I don't like the way they handle this. So now take all 5 of these, triangle, triangle, front side, and the two back sides, and add all of these together to get your grand total. 12 and 12 is 24, plus a 56, 70, 80. 35 and 35 is 70. So add 70 onto there. You get 150. Label your answer. Square feet. Boom. Okay. All right. Here's another one of these weird ones. Okay. And notice that if I'm just doing surface area, this is similar to the plant stand problem, but on this one, on the big box, we're actually going to do the bottom on here, okay? Let's just find the area of both of these little cubes, and then let's subtract out the part that you can't see, which is going to be this little overlap stuff on the bottom, okay? Big box. The big box has 6 sides. The front and the back are 7 by 11, okay? So 7 times 11 is 77. You have 2 of those. The left and the right side are these two, and they're 9 by 7. Okay, so do 9 times 7. That gives you a 63 and a 63. The top and the bottom are 11 by 9. 11 by 9. That's 99, and you have 2 of those. Cool. We'll get that grand total in, well, you might as well do it right now. And frankly, I'm going to use my calculator too, because like I said, I haven't had enough coffee. 77 times 2 plus 63 times 2 plus 99 times 2. I think I get 478. That's actually this one, okay? That little cube up here, let's take a peek at that guy. Oh, for goodness sakes, what's messing up my computer here? All right, the little cube is 2.5 by 2.5 on every face, okay? Multiply that to get one face, and that should be about 6 1/4. You have 6 faces, so you have to take 6 times 6.25. All right, oh, good gravy, what is that? 36 and 1.5, is that 37.5? 6 times 6.25. I don't trust myself. 37.5, okay? There you go. Now, if I add those two together, okay, so that's what they're asking you to do here. 37.5 and 478. But here's the deal. We have the bottom of the baby cube right there, which is a 6.25 square meter area. And it's also covering up that square on the top of this one. So what you're going to have to do is subtract off 2 of those. That total is 12.5. Okay, so you're going to add 37.5 plus 478 minus this 12.5. And I get, oh, exactly 503. Does that sound right? I'm going to double check that again because I don't always trust it. Okay. 37.5 and 478. Yep, that's what we get. Cool. Okay. How do you find the surface area? Find the area of each face. add them up. That's really the fastest thing to say there. All right. Turn the page, and here's what I want you to do. Number 4. Number 5. Ooh, this is such a good one. Number 6. 4, 5, 6, and let's work on 10 and 11. Okay. We'll talk about those when we get together again. Good luck, and may the force be with you.